This video is a short demonstration of liquefaction in sands and the potential effects on building foundations. Liquefaction is a phenomenon that can occur in sands during dynamic loading, such as would be experienced during an earthquake. During an earthquake, the shaking can cause sand particles to move closer together under the action of gravity. If the space between the particles is occupied by water, this causes a corresponding rise in hydrostatic pressure. This excess hydrostatic pressure causes a decrease in effective stress and a rapid and dramatic reduction in the strength of the soil beneath the foundation. This can cause foundations to fail in bearing capacity or in overturning due to differential settlement. Some of the other effects of liquefaction that can damage infrastructure include sand boils, such as experienced during the New Zealand earthquake, overturning of building foundations, and lateral spreading. In this demonstration, a steel weight is supported on a metal disc in order to simulate a shallow foundation. The model foundation is then placed on a loose sand surface. The hammer is used to simulate the dynamic loading that may be experienced during an earthquake. Observe that there is some small deformation occurring under non-saturated, that is, non-liquefiable conditions. Next, the sand is saturated. Notice the water level moving from the bottom of the tank to the sand surface. Now, the model foundation is subjected to the same dynamic loading under saturated and liquefiable conditions. Notice the much larger downward movement of the building as the sand begins to liquefy. The next demonstration represents a potential failure mechanism in a deep foundation system during liquefaction. The thin metal rods are used to represent deep foundation elements such as driven piles or drilled shafts. Again, there is some movement observed during dynamic loading in the unsaturated example. However, when the same model foundation is subjected to dynamic loading under liquefiable conditions, the failure is much more dramatic. Thank you.